In this video, we'll be trying to solve more questions on AC circuit problems in physics. This is a continuation on our previous class on AC circuits, okay? If you missed our previous class on AC circuits, I'll leave a link to the previous class in the video description. But for this class, let's look at this question here. So we're given this diagram here, and we're asked to, from the diagram, we're asked to calculate the following in the series circuit shown above. All right, so here's a series circuit, as you can see here. You asked to calculate the following in the series circuit shown above. That's the circuit here. All right, the first thing you ask to find is the reactance of the capacitor. The second thing you ask to find is the impedance of the circuit. The third thing you ask to find is the current through the circuit. The fourth thing you ask to find is the voltage across the capacitor. The fifth thing you ask to find is the average power used in the circuit. Okay. Now in this question here, I want you to note two things. Your focus is usually either on the capacitor, as you can see here, this and number 4. You can say this, both talks about the circuit, or both talks about this capacitor. So the first thing to observe here is that if you look at this clearly, you can see they mentioned capacitor here, and also on question 4, they also mentioned capacitor. So question 1 and question 4 focuses on the capacitor, while question 2, question 3, and question 5 talks more about the circuit. All right, so when it comes to solving questions on the capacitor, we'll focus on the capacitor. When it comes to solving questions on the circuit, we'll have to focus on the circuit. Okay. All right, so in solving this question here, our first start would be to list out the given parameters. Okay, let's list out parameters. All right, so I'm giving, what am I giving in this question? That becomes our first task. So in this diagram here, your ability to pick out your values given is dependent on if you know what the symbols represent. For instance, if I have these two slash like this, if I have this and then this, what does it represent in a circuit? And the answer is simple. That represents the capacitance. So solution there. Okay, so solution, let's list out the given parameters. So given, based on the symbols there, the first thing I'm given there is the capacitance of the capacitor, that C has been equal to, if I look at the capacitance here, is 20 microfarad, and that's equal to 20 microfarad. Now let's convert this to farad. This is equal to, this becomes 20. Note that micro is equal to 10 to the power minus 6. All right, so when you have a micro, so if you say 20 microfarad, it becomes 20 times micro is 10 to the power minus 6 farad. So the first thing we've gotten there is the capacitance as 20 times 10 to the power minus 6 farad. That's the first thing. The second thing we can find there is this symbol here. All right, this symbol here. So when you have a block like this in an AC circuit, a block like this, what does it represent? A block like this represents resistance. Okay, so note that resistance comes in two forms, either this way, if you have this, something like this shows resistance, or this one here, this also shows resistance. All right, so there are literally two symbols for resistance in a circuit. So in this case, it means that we're also given resistance. So number 2, we're given the resistance, that's R. The value of the resistance R, it's equal to, if I look at this, the value that is given here as 1,500 ohms. I'm having 1,500 ohms. That's the resistance. What else do I have? If I look at this, you can see this. Now, what this represents, if you have something like this, okay, what this represents is actually the voltage. It gives the voltage and the frequency supply. All right, so this is used to represent the voltage and the frequency supply of a circuit. So if you look at this now, below this, you can see that you have a voltage of 75 volts and a frequency of 30 hertz. So the first thing I'm giving there is voltage. To number 3, I. You're giving voltage, that's V, as equal to, the voltage value is 75 volts. So this is 75 volts. That's III. IV, you're given the frequency. So frequency, that's F. The value of the frequency from here, as you can see, is 30 hertz. So F is equal to 30 hertz. That's the frequency. All right, so with this now, we've picked out the parameters given the question. Let's now go straight to solving the questions. I says we should find the reactance of the capacitor. So let's look at I. Let's call it capacitor reactance. Capacitor reactance. In our previous class, we discussed what a capacitor reactance is. We said it's simply the opposition to the flow of current in the capacitor. That's the reactance. Okay, that's the capacitor reactance. And it's represented by XC. And we said XC is equal to, the formula for this is 1 all over 2 pi FC. That's your formula. That becomes 1 all over 2 times pi into F. So the F is frequency. The frequency, as you can see here, is 30 hertz. 2 pi frequency 30 times C. C is your capacitance, whose values you can see here is 20 times 10 to the power minus 6. That becomes 20 times 10 to the power minus 6. So I have this. And that's equal to, so I'll just get my calculator and punch this. So I'm having 1 divided by, let me confirm that this is 20. All right, so that's correct. Okay, let's see. 1 divided by 2 times pi times a frequency of 30 hertz times the value for capacitance. And when I punch this, I have my value here as, let's call this XC as being equal to, my value gives me 265.26 approximately. All right, in today's math, I have 265.26. Now we said X is reactance and it's measured in ohms. Okay, it is the opposition to the flow of current in the capacitor. Okay, and it's measured in ohms. So we've gotten the first part there, the reactor capacitance. The second thing we ask to find is the impedance of the circuit. So II, let's get circuit impedance. So II, let's look at how to find circuit impedance. Now the concept of a circuit impedance is almost the same thing as the reactance. Okay, what's the difference? The difference now is that if you talk about the reactance is the opposition of current, or the opposition to the flow of current in a single element, which in this case is a capacitor. While if you talk about the impedance, is the same concept, which is the opposition to the flow of current, but in this time in the entire circuit, including all the elements. The elements majorly here are the capacitor, that's this one here, and the resistor. In essence, the impedance becomes the impedance for the resistor and capacitor. So it becomes ZRC. R for resistor and then C for capacitor. So ZRC. So we have this. That's the circuit impedance. Now, when it comes to finding your circuit impedance, what's the formula for this? Now, the formula for this, for a resistor capacitor circuit, ZRC, the impedance is simply equal to the square root. Your formula is simply equal to the square root of R squared, so R squared plus XC all squared. As I said, we've explained all of this concept in our previous class. I'll leave a link that explains all of this from scratch in the video description. So when you're done, check the video description. You see a link to our first class on AC circuit that explains all of this from scratch. Okay. All right, let's proceed with this. So this is equal to the square root of R squared. Let's see, R squared. What's R? Going back to the question, R is equal to 1,500 ohms. So you can say this 1,500. So I'll come here. So R is 1,500 squared. That's R squared plus XC. XC is 265.26. That becomes 265.26 all squared. All right, so we have this. All right, so let's solve this. So from here, Z, the impedance of the circuit for the resistor capacitor circuit, is equal to, so just go straight to punching this and see what I have. So square root of 1500 squared plus 265.26 squared. If I punch this with my calculator, my solution here is 1523.27. Okay, this is also measured in ohms. All right, so it's also in ohms. So this becomes my answer, 1523.27 ohms. So this is the solution for the circuit impedance. What's the third thing there? The third thing says we should find the current through the circuit. Now, emphasis on circuit. Let's look at I. Let's call it circuit current, okay, or current through the circuit, whichever one, same thing. Circuit current. Let's get the current in the circuit. All right, so how do we find the current in the circuit? Now, from Ohm's law, we know that V is equal to IR, okay, where R is simply the resistance. But when we talk about the circuit, this circuit is a resistor, or the circuit contains a resistor and a capacitor. So hence, we don't just use the resistance, that's R. No, we use the impedance of the circuit, which is ZRC, this one here. So it becomes V is equal to I, then ZRC, right? So instead of R, we use ZRC. This is like the basic concept for this, okay? All right, with V is equal to I ZRC. From here, let's find I. From here, I'll divide here by ZRC, divide here by ZRC. This cancels this. So you have that I, the circuit current, is equal to the voltage all over ZRC. So all over ZRC. Let's bring in values. What's the value for the voltage? If you go back to the question there, voltage V, let's see this. Okay, look at this. Consider the value of the voltage V is equal to 75 volts. All right, V is 75 volts. That becomes 75 volts V all over ZRC. What's ZRC? Okay, we found that. Yep. So see our value for ZRC, this one here, you can see there. So this is the value we got when we found ZRC, 1523.27. Okay, so divided by 1523.27. Okay, let's do this division. So it becomes 75 divided by 1523.27. Okay, my answer here is 0.049, approximately 0.049 approximately. So this is the value of the current. Of course, current is measured in amperes, so this in amperes. So here's the value of the circuit current. That's III. Let's look at IV. IV, what are we asked to find in IV? All right, for IV, what's the question there? IV says we should find the voltage across the capacitor. All right, voltage across the capacitor. So in this case, how do you find the voltage across the capacitor? So I'll just call this capacitor voltage. Capacitor voltage, or voltage across capacitor. How do you find this? Again, from Ohm's law, V is equal to IR. Basically, now when we talk about the capacitor, it becomes not just V, but VC. VC means capacitor, voltage of the capacitor. That's mean of VC, okay? It's equal to I. I is current. Now, if you look at, when we mention XC, this, I said, reactance is simply the opposition to the flow of the current in the capacitor. In essence, this represents the resistance of the capacitor. So if V is equal to I times R resistance, in this case, we use the reactance XC since they mentioned capacitor. All right. So XC is called the reactance of the capacitor, which is like the resistance of the capacitor, if you want to put it that way. So here, this one becomes our formula. With this, what exactly is the value of the voltage of the capacitor? That's what we asked to find. This is equal to the current of the capacitor, or the current of the circuit, which is this one here, 0.049. We already calculated this as 0.049. So this into xc. Xc is simply the reactance of the capacitor, which is actually 265.26, 265.26, 265.26. We have this. So from here, Vc, that's voltage of the capacitor, it's equal to 0.049 multiplied by 265.26. If I multiply this gives you about 12.997, which is approximately 13. So I have 13.00 or 13 volts. The 13 volts becomes the voltage of the capacitor. All right. Let's get one final one there. V, the final thing there. What's the final question there? Let's look at this one here. Final question. Final question says you should find the average power used in the circuit. All right, average power used in circuit. So I'll just take this down. Average power used in circuit. What's the average power used in circuits? Now, note that the formula for power, P, is equal to IV, but we know that V is equal to IR. If I bring this here, it means that P is equal to I. We said V is simply IR. Let's multiply this. That becomes I times I, which is I squared times R. So the formula for P, for power, P is equal to I squared R. So this is simply equal to the square of the current. Let's look at the value of the current again. The value of the current again, if you look at this, it's 0.049. So 0.049 squared, 0.049 I squared. Let's get R, the resistance in the circuit. All right. Going back to my initial question, we'll see that they gave us a resistance R as equal to 1,500. That's this value you have here, 1,500 ohms. All right, so having said that, I'll just bring in that value here and see what we get. So this times 1,500. Okay, so hence the power P is equal to, I'll just go straight to punching this, 0.049, this all squared multiplied by 1,500. The value here is 3.60, so 3.60 or 3.6, okay, you can add a 0 here, is insignificant, so I'll just use 3.6. Now power is measured in watts, so that's a capital W to mean watts. So I have this, okay. All right, guys, so this is how you solve this question, okay. Now I want to give you a task here. All right, let's look at this. Now if you look at the value of the resistance, the value of resistance is 1,500. Okay. Now let's say I am to reduce. Let me give you a task. Reduce this value. Let's see how many of you can get this. Reduce the value of R, the value of R by let's say 50%. Then calculate the average power. Calculate the average power. All right, so here's a tricky question for you. All right, so your question is simple. Use all the values as the same thing here. The only task I'm giving you here is to reduce the value of R, that's 1,500, reduce it by 50%. What will your answer be? Leave your answer in the comment section. Then next up, use that new value of R to find the average power. All right, follow my method. Use the same value of the current, find the average power. Leave your answer in the comment section. All right. So when you get your answer, leave it in the comment section and I'll tell you if you're correct or not. Okay. All right, guys. So Don't forget you can get access to over 100 classes on physics, chemistry, mathematics, right? Where I've dealt with the major topics in JAM, including JAM past questions and solution for the past 10 years. You can get it from my website. Simply visit www.jonahimmanuel.com/courses and you see the JAM/WAEC course. Okay, register an account to the website and then proceed to get the course, or you can simply join my JAM/WAEC membership group so that you can get access to exclusive contents for JAM and WAEC students. Okay, I'll leave a link to both my website and to join my JAM/WAEC channel membership in the video description. All right, so check video description for a link to join my membership group. Okay, all right, guys. So if you enjoyed this video, as usual, please hit the like button. All right, so please like this video. All right, hit the like button. Leave a comment. For your comment, I gave you an assignment or a task. All right, I said reduce the value of the resistance by 50%. What would the value be? Leave it in the comment section. Also, use that value of R to find the new average power. Okay, leave your answer in the comment section and I'll tell you if you're correct or not. Don't forget to subscribe. If you're yet to subscribe, please help us subscribe as it helps us to grow. Hit the bell icon and choose all so that you get notified whenever we upload a new content. And finally, share this video to your friends so that they can also learn. Thank you and see you in our next class.